types of chemical reactions. So this first one I want to show you is called a synthesis reaction. You notice that we have a balanced chemical equation here of aluminum bromide, okay, aluminum and bromide on one side and aluminum bromide on the other, okay. And so you have these two elements which yield one compound. Okay, so I want you to watch the video and then come back to the notes. Watch this video, it'll be posted with uh, where you found this video and the notes. So chemical reactions can seem unpredictable and chaotic, like the aluminum and bromine reaction you just watched. But when you know the reactants, you can analyze what is happening and explain what you observe. The product of this spectacular reaction can be determined by experimenting to be a molecular compound called dialuminum hexabromide. Okay, the chemical reaction is as follows. By studying thousands and thousands of interactions among chemicals, chemists have developed a classification system for chemical reactions. This system helps them analyze familiar reactions and predict the products of new reactions. The first one I showed you, a synthesis reaction, is a chemical reaction in which two or more reactants combined to form one new product. Synthesis reactions can be represented by a general chemical equation and pictorially as this. My advice as you're going through is, as you're beginning to, right, if you have two elements, place an A and a B underneath them. Then it will yield, if it yields AB, as in it yields a compound on the other side, which is a combination of the A and the B, then you have what is known as a synthesis reaction. Okay, just as you're learning, sometimes it's helpful. The reactants may be elements or they may be compounds. Okay, so you might have a compound and an element, or an element and a compound, but you'll always end up with one compound in the product section. When a synthesis reaction occurs between a metal and a nonmetal, it involves the transfer of one or more electrons to produce ions. Therefore, the product is an ionic compound that is a combination of two elements. The ion charges can be used to predict the product. Okay, so a synthesis reaction between sodium metal and chlorine gas produces sodium chloride. Okay, since the sodium ion has a charge of 1 plus, and the chlorine ion has a charge of 1 minus, the product is NaCl. You see it as a balanced equation down here. So this is a video of a reaction of sodium, metal, and chloride. So you can go again to where you found the other video and watch this to see how basically table salt is. You can create table salt with these raw elements. The incredible power of the main thrusters in the space shuttle is generated from a synthesis reaction. Liquid hydrogen and liquid oxygen react to produce something. Okay, now take a look at this and try to think about what they will produce, what they will react to produce. We have two H2s, and we have four H2s, and we have two O's. Okay, so what do you think it's going to produce? If you said water vapor, you're correct. Okay, it produces H2O. Now, the second one, a decomposition reaction is a chemical reaction in which a single compound breaks down into two or more products. Decomposition reactions can be represented by a general chemical equation and pictorially. Okay, as here you can see, this is the opposite of a synthesis reaction. We have a compound and it yields two elements. Okay. The product may be a combination of elements and compounds, but the reactant is always a compound. Okay. Decomposition reactions can be thought of as the opposite of synthesis reactions. So water undergoes a decomposition reaction to produce hydrogen gas and oxygen gas according to this chemical equation. Okay, so this balanced chemical equation, we have water, H2O, and it yields hydrogen and oxygen. Electrical energy is used to break apart the chemical bonds between hydrogen and oxygen in water. This process is called electrolysis. If you watch this video, it's actually a very simple way that you can even do at home to separate oxygen and hydrogen in water. You still want to be careful though, because hydrogen is flammable, right? And so it's combustible. Okay, now this is an example of a decomposition reaction. The decomposition of hydrogen peroxide creates a very exciting reaction. So go back to where you found the other videos and watch this elephant toothpaste video that Bob Flugfelder does on this show. Here's the reaction. In a single displacement reaction, okay, so here's our next one. An element and a compound react to produce another element and another compound. The element reacting can be a metal or a nonmetal. This type of reaction is one in which the element takes the place of or replaces another element in the compound. Okay, so single displacement reactions can be represented by general chemical equations and pictorially this way, right? So if we had A plus BX, all that's going to happen is, let's say this is a metal. These are two metals, and the X is a nonmetal. Okay, that would mean that the nonmetal would switch places with the other metal. Okay, so that the metals would switch places, and then you'd end up with AX plus B on the other side of the equation. You may also have a situation where you have a metal and two nonmetals. Okay, and then of course the nonmetals switch places. Okay, with the metal or with each other to form a new one. Remember that about single displacement and double displacement actually. Metals can only switch with metals and nonmetals can only switch with nonmetals. So the equation representing a reaction involving a metal element replacing the metal ion in a compound, and the second equation represents a reaction involving a nonmetal element replacing the nonmetal ion in a compound, which I guess I just went over with you. When aluminum foil is added to an aqueous solution of copper 2 chloride, the products are aqueous aluminum chloride and solid copper metal. The chemical equation for this reaction is this, okay, down at the bottom there. We have aluminum, copper, and chloride. Okay, and they yield, and you can see here now that the metals, these are the two metals, aluminum and copper, right? So now aluminum is with chloride and copper is by itself. Because hydrogen ions are positively charged, some metals can take the place of hydrogen in compounds. Hydrogen's always breaking those rules, right? The element formed in this type of single displacement reaction is hydrogen gas. And so we have zinc, which is a metal, and hydrogen, which is a nonmetal. But remember, it acts like a metal. It only has one valence electron, right? And so it switches places with zinc. An example of the second type of single displacement reaction is a reaction of chloride gas with sodium bromide. Okay, when chlorine gas reacts with sodium bromide, the chlorine replaces the bromide in the compound, forming sodium chloride and bromide. So again, you have bromide and sodium together, right? Sodium is going to now, or bromide and chlorine are going to switch, or chlorine are going to switch, right? So now it is sodium chloride and bromide, or bromine, rather. Okay, another example of a single displacement reaction is shown in which copper metal, an aqueous solution of silver nitrate. Okay, so we have copper metal, a coil of copper metal, and we have an aqueous solution of silver nitrate. Okay, AgNO3. And it's pretty cool. This is a video that I made, a time-lapse video. Where you can see an aqueous solution. Okay, it started off clear as silver nitrate, right? And then we have the copper in there. The copper reacts, right, and is replaced. The copper is replaced with these things right here. That's silver. That's in the aqueous solution. It's being replaced, and then that blue color is actually indicating copper, the copper nitrate. So the flask on the left shows a copper coil. Okay, this was from the original picture. Added to the silver 2-nitrate solution. The flask on the right shows what happens when a copper coil is left in silver nitrate solution overnight, or like I showed you, time-lapsed. The reaction is represented by this chemical equation down at the bottom. Okay, so we have these guys here. In this reaction, the copper metal replaces the silver metal ion in the compound. As this occurs, metallic silver forms on the surface of the wire. In addition, the solution turns blue. This is because copper atoms from the wire become copper 2 ions and dissolve in the solution. When copper 2 ions are dissolved in an aqueous solution, they cause the solution to turn blue. In the above reaction, a metal replaces a metal. Okay, because a metal forms a positive ion, it must replace the positive ion from the compound, also a metal, so that a new ionic compound is formed. The ion of a nonmetal, such as bromine ion, is negatively charged, so it can only be replaced with another nonmetal. Okay, double displacement reaction. In a double displacement reaction, the positive ions of the two compounds change places to form new compounds. The reactants of a double displacement reaction are often aqueous solutions of ionic compounds. Double displacement reactions can be represented by a general chemical equation and pictorially as follows. Okay. In this equation, A and B are positive ions. Okay, what is positive? They are metal, and X and Y are negative. Okay, so you can see here, the A is now with AY is now with AX over here. BX is now with BY over here. I want you to watch this video okay, on precipitate, okay, precipitation of silver chromate, a double displacement reaction. An example of a displacement reaction is the mixing of silver nitrate with potassium chromate. Okay, like in the video you just watched, when a colorless solution of aqueous silver nitrate is added to the yellow solution of aqueous potassium chromate, the red solid silver chromate forms or precipitates. This is the equation for the reaction that we just watched. We have silver nitrate and potassium chromate. These are both compounds. And what are they doing? Silver and nitrate that were together are now silver and chromate. Okay? Potassium and nitrate are now together. Remember, this is the key. Matter is neither lost nor destroyed. It's neither created nor destroyed. Okay? So whatever you have on one side, you're going to have on the other side. And it's just getting used to which ones switch with what. The last one we're going to talk about is a combustion reaction. Okay? And this is a chemical reaction in which a compound or element reacts with oxygen to form a compound called oxides. The oxides formed contain oxygen and elements that make up the reactant compound. For example, compounds containing sulfur combust to produce sulfur dioxide, or SO2. Okay, here's another example, methane. Methane plus oxygen yields carbon dioxide and water. Another characteristic feature of combustion reactions is that many produce heat and light. The burning of fuels such as wood, natural gas, and gasoline to heat buildings and power vehicles involves combustion reactions. Organic compounds are common reactants with oxygen in combustion reactions. An organic compound is a molecular compound that contains carbon. Note that carbon monoxide and carbon dioxide are two exceptions. They're not considered organic compounds. Nearly all organic compounds are composed of a backbone that is made of carbon-carbon bonds. Hydrocarbons are a type of organic molecule that contains only the elements carbon and hydrogen. Methane, CH4, okay, the main component in natural gas, is a hydrocarbon that undergoes combustion with oxygen to produce carbon dioxide and water. The flame and heat produced on a gas stove is due to the combustion of methane, a general equation for the complete combustion of hydrocarbons. Okay, and so we have, and this is going to be important for you to remember, okay, in this general equation, CH is the general formula for hydrocarbons. Okay, X and Y represent the integers. For example, CH4, okay, where X is equal to 1 and Y is equal to 4. Now, one thing I want you to realize is that, we'll go over that in a sec. Many organic compounds contain oxygen in addition to carbon and hydrogen. These include carbohydrates, which are molecules used by our bodies as a source of energy. The overall chemical equation for the burning of carbohydrates or glucose by our cells can be written as the following combustion reaction. Okay, so CHO, that's a carbohydrate. So C5H12O6 or C6H12O6, okay, plus 6 oxygens, okay, yields carbon dioxide and water, right? That is part of respiration. Now, it's important that you realize whenever you are identifying if something is a combustion reaction, you will always have oxygen. Okay, so you'll always have either CHO or you'll have CH here, and you're always going to have plus oxygen yields carbon dioxide and H2O or CO2 and water. Okay. The overall reaction is the same as the combustion reaction, but the process takes place over many small steps. In this way, energy is released gradually in the form the body can use rather than a large quantity of heat and light. If the supply of oxygen is too low, incomplete combustion reaction occurs. Like incomplete combustion produces carbon dioxide and water, but incomplete combustion also produces carbon or soot and carbon monoxide. Carbon monoxide is a colorless, odorless, highly toxic gas. This is why it's a good idea to have a carbon monoxide detector in your home, usually close to your bedrooms, not close to the furnace, if it's gas furnace. Carbon monoxide prevents oxygen from getting to cells that need it because it binds with the hemoglobin in your red blood cells 200 times more strongly than oxygen. Okay, so that's you can actually suffocate. Okay, so this is a summary of what I want you to know. Okay, we have the reaction types on the left. In the middle, we have the general equation, and on the right, we have the characteristics.